Every transformative innovation starts with an idea. Your idea. Your ideas can change the world, take you to new heights. They can even take you to whole new worlds. And even to the edge of the universe. Wherever your ideas take you, Xilinx is there. We are building the adaptable, intelligent world with you. Please welcome Xilinx President and CEO, Victor Peng.
Express yourself. Express yourself.
Thank you. Good morning. Welcome to XDF 2019. So discovering the Higgs boson, sometimes modestly called the God particle, landing an autonomous rover on the surface of Mars, finding evidence of water on an asteroid 1.2 billion miles away. These are just some of the breakthroughs that innovators like all of you in this room are achieving with our products. So here on Earth, where most but not all CEOs reside, you're building applications in communications infrastructure, medical and life sciences, industrial application, transportation, and of course, computing both in the cloud and the edge. It's incredibly exciting to see the intelligent connected world actually becoming a reality, and many of you in this audience are making that happen with our products and with our platforms. So you may have heard me talk about our strategy, and if you haven't, I'll just go through very quickly. Just three simple elements: data center first, accelerating growth in our core markets, and driving adaptive computing. Now, one of the ways I think about this strategy is that it's really all about empowering more hardware and software developers like you with our uniquely powerful and adaptable platform. We've made phenomenal progress since last year's XDF, and you're going to hear all about it today, and more importantly, you're going to see it throughout this forum. So I really encourage you, you'll hear me give some shout outs to some of the things that are out on the floor. So I'm going to really talk about what we've accomplished in the past year, as well as where we're headed. And I'm going to focus on markets that are going through some really significant transformations. And again, many of you are driving that transformation. And we expect that to be driving a lot of growth for Xilinx. So these growth drivers map directly to two of our three strategies. Obviously, data center maps directly to the data center first element of the strategy. 5G and automotive are two of our traditional core markets. We've participated in those markets for well over decades. And we really see that as tremendous growth. And the third element is driving adaptive computing. And we really see that getting momentum across all markets. Okay, so let me start with 5G infrastructure. Last year, as many of you know, South Korea led the world in deploying 5G base stations, and our 16-nanometer UltraScale Plus products were in those base stations. But instead of me going on and talking about the deployment of 5G, I'd like to bring on stage someone who's directly making that happen. So I'm delighted to welcome the Vice President and Head of Technology and Strategy at Samsung, Dr. Won-Il Roh.
Thank you so much, Victor. Good morning. So 2019 is the first year for 5G commercial mobile service came into the commercialization. And unlike many in the industry have predicted in the past, the rate of acceleration and commercialization is at a rapid pace. And according to this GSMA report, as of August this year, there are 56 operators in 32 countries have deployed at least one or more base station radios in their commercial network. Out of all these countries, there are two countries, the United States and South Korea are the leaders, mainly because they are the first one to go commercial in live network in April this year, and also they are the one who deployed in a sizable volume. The countries that follow is the Japan, and last week Japan opened up the Rugby World Cup with the pre-5G commercial network, but the full-blown 5G service will start March next year in preparation for the Tokyo Olympics. And last but not least, the India. I believe this is the country when there is telecommunication revolution took place in the last 3 years, and they will auction off the 5G spectrum either in late this year or the early next year. And I believe that the India will be the next big 5G market. United States has been the pioneer when it comes to 5G commercial because they have commercialized 5G in range of spectrum. First, they have started this 5G commercial service for fixed wireless broadband access service last year using millimeter wave bands. And this year, they started this mobile 5G in millimeter wave bands as well as mid-band. And I expect some more activities for commercializing 5G in low bands in the near future. And Samsung, as a leader in telecom equipment provider, we have provided our equipment to meet this customer's needs and site environments. For example, all this product that we have shipped to the United States start with this 5G millimeter wave base station that we have shipped last year for fixed wireless access application. And this product is small enough so that the operator can set them up on the poles or street lamp to bringing down the CapEx and OpEx for the carriers. And this year we have shipped the mobile base stations for millimeter wave bands. And for those operators with mid-band, we have shipped this massive MIMO radios that supports LTE and 5G simultaneously to enable this 4G, 5G seamless handover. Lastly but not least, we also will provide this 5G 39 gigahertz Pico radios later this year. Let's pay attention to Korea. And this month, Korea, the number of subscribers in Korea is more than 3 million. And this is the edge of September. And this achieved over just 5 months after its launch in April. And this rate is faster than LTE, compared with LTE days. And this, according to this GSA report, I don't have the latest number, but GSA report in June, Korea accounts for more than 80% of global 5G subs. So how this is possible with this rapid growth in 5G in Korea is mainly due to the very extensive 5G network coverage. So all three carriers altogether, they are providing this 5G mobile service in 85 cities with the 180,000 radios, and that number will reach about 230,000 radios by the end of this year. And we target to provide the nationwide coverage by the end of 2021. And Samsung currently holds the largest market share of 5G network in Korea, providing both radio solution as well as core solutions. And this was made possible mainly due to providing these customer requirements and delivering these slim massive MIMO units. And that's compact enough for the carriers to put them in a conventional site without any problems. This all success, the early success of 5G, the Samsung success in the early 5G market is mainly the two reasons. Number one is meeting the customer's requirement. Number two, providing the product very quickly. And these two is mainly the result of our enduring partnership with Xilinx. And because Xilinx FPGAs has very flexible hardware accelerations and low latency operations, high-speed switching capabilities, as well as low power consumptions, all these are very critical to make our product very competitive. So these competitive Xilinx devices play an essential role in our digital units and our massive MIMO radios, as well as millimeter wave base stations. So with this new and exciting state-of-the-art product coming soon, which I mean is Versal ACAP, with this integration of AI engines as well as low latency and high throughput, and the highly integrated SoC capabilities. And Samsung will try to leverage the strengths offered by Versal and try to optimize our product in performance and size and weight. So together with Xilinx, I'm very confident that we will continue to deliver our best-in-class product in timely fashion. So thank you.
Thank you. Juanio, thank you so much. Collaborating together on the first deployments in 5G with our UltraScale Plus, and now we're super excited about engaging together on the next deployments in the future with Versal ACAP. Thank you so much.
Thanks so much.
Thank you. Yeah. Okay. All right. Thank you. Yeah. Give it up. So last year we also talked about our continuing transformation of the platforms, and that's when we first shared Versal, the Versal architecture, including the AI engine, which you heard Juanio talk about, as well as the various product families. Since then, we've taped out Versal, and we've shipped those silicon to customers, and you'll hear more about that. Last year, we also unveiled the fact that we were launching the Alveo board business, right? So we had our very first PCIe acceleration card for data center, and today we have 4 Alveo boards shipping in production based on UltraScale Plus. The first product was the U200. We followed up with a more powerful U250. And then we have the U280 that has integrated HBM as well as multiple DDR channels for the ultimate in performance. Most recently, we announced a U50 that has integrated HBM, but in a half height, half length form factor. So really packing a lot of performance in a 75 watt kind of overall board budget. So really powerful lineup. Now, excited as we are about what we've done in the past year in Versal, in ACAP, Alveo, we're more excited about what we're doing in the ACAP products. So I'm going to show you, first I want to introduce to you what we believe is the most advanced processing chip ever made. It has 36 billion transistor, 7 nanometer Versal ACAP. So I know, last year it was PowerPoint, now we got the real goods. The second thing I want to show you is the first Versal PCIe development board, okay? So, now in the past as we just launched our Alveo business, we haven't really had development boards as rapidly, but you can count on us moving forward that we always have development boards as soon as we have silicon for new architecture, and of course we're going to have production boards as soon as we have production silicon. All right, so I encourage you to check out applications running on these development boards. There are multiple of them in the concourse area. So this brings me to the next major market that we talked about driving growth, and that's data center. So last year at XDF, we were just launching that very first Alveo board, the U200. So of course, we're just beginning to build an ecosystem, an ISV ecosystem, hardware and an ISV ecosystem around Alveo. So we made really great progress over the past year growing both of them. We have major OEMs signed up like Dell, HP, and Inspur. We've also signed up major VARs and distributors like Colfax and Ingram. And on the software ecosystem front, we've got a growing number of ISVs doing applications like video, data analytics, machine learning, health sciences, and finance. And of course, there's more developers. We've trained close to 6,000 developers over the past year, and we have over 700 accelerator partners in our accelerator program. There are 85 production applications now listed on our website between AWS's F1 and our Alveo ecosystem, and there are many more applications under development. So again, you can see some of these accelerated apps in the current Alveo out in the concourse area. So what I'd like to do now is to bring on stage key leaders from Amazon Web Services. And as you all know, Amazon was the first to have the vision of FPGA as a service and the first to roll out that offering. And they've been absolutely instrumental in the growth of accelerated applications based on FPGAs. So please give a very warm welcome to Senior Director of Business Development at AWS, Gadi Hutt, and the Head of Engineering for Amazon Neo, Vin Sharma.
Hi everyone, we're excited to be here today to talk about AWS and the FPGA instances. I would like to start with the famous Gartner Magic Quadrant for Cloud Service Infrastructure as a Service. We are very proud that AWS is the leader in that segment for the 9th consecutive year now. And there are many reasons why AWS is maintaining this leadership position. One of the most important ones, in my view at least, is our customers and our passion to develop the best for them. This is a partnership with a deep commitment from our side to ensure our customers can focus on their core business expertise and best serve their customers, while we focus to innovate on the infrastructure around the globe, on the services and the tools that make all of that possible. One example of our cloud segment leadership is our global infrastructure. AWS Cloud spans 69 availability zones around the world. Each availability zone comprises of multiple data centers, just to give you the sense of the scale. And those are deployed in 22 geographical regions around the world. And we continue to invest and innovate. We just announced plans for 9 more availability zones and 3 additional regions coming soon in Cape Town, Jakarta, and Milan. Since we launched the FPGA instances in 2017, we doubled our capacity worldwide with a total of 8 regions around the world. FPGA, which means that FPGA application developers can now launch products globally with a few clicks of a button and do that at scale that isn't available anywhere else in the cloud. Any Canadians in the room today? Yes, one. Good. So today, I'm very happy to announce that we just added the EC2F1 into our Canada Central region in preview. And we'll continue to do so as customers come and give us more use cases and want to start businesses in other regions of the world. So let's move on to see a few examples of what customers are doing with AWS FPGAs. AstraZeneca is one of the world's largest pharmaceutical companies. They were able to build what is possibly the fastest and most operationally efficient genomic sequencing data processing pipeline in the industry. The solution is using the AWS FPGA instances to crunch the genomic data securely, and many other AWS tools and services, most notably AWS Batch for job queuing, and the highly scalable and secure S3 storage. It's important in the genomic industry and other industries to maintain security. We're talking about genome data that comes from humans, and we are very proud that companies like AstraZeneca rely on AWS and our FPGAs to process that data. As of late, they pipeline processed more than 100,000 genomes, and they did that in 100 hours. As a comparison, if they would do that on CPUs, it will take them more than 3,000 hours and an order of magnitude more expensive to do so. And by the way, they reported that the results that they received with the FPGAs compared to CPU were more accurate. So this is helping them drive research in cancer and other chronic diseases, and we just can't wait to see results of that great work. AstraZeneca believe that they can run it even faster with improvements to the pipeline that we identified together. And in total, they plan to analyze around 2 million genomes by the year 2026. So it's truly an amazing feat. Talking about security, Trend Micro is a leading enterprise network security provider that just launched a high-performance version of their network security appliance on the AWS Marketplace. Trend Micro relies on AWS FPGAs instances to deliver network security solution that with unique advantages such as predictable network application performance and unparalleled efficiency and operational simplicity. giving our AWS enterprise customers the ability to span from on-premises trained micro appliances directly to the cloud with one pane of glass control and in a way to control their overall infrastructure in a secure way. I want to take a moment and recognize our FPGA cloud segment leadership could not be possible without our great partners. Many of them are here today with us in this room. When we launched the service, we only had a handful of partners, literally handful. And we invested a lot in kickstarting the ecosystem together with Xilinx, Victor and the team. And today we have more than 50 qualified partners, more than 35 applications on the AWS marketplace that allow AWS customers, that most of them don't even know what an FPGA is, to easily explore, test, and instantly deploy FPGA-based applications at a global scale. Therefore, accelerated solutions span many segments of the market, from security to video and imaging, processing, data analytics, fintech, and general HPC applications. One of the coolest things are that Amazon teams themselves started to adopt FPGA technology on this very stage last year. Twitch and Edge Codec jointly announced the video encoding solution that runs on AWS FPGAs. And I just can't wait to see what more will come in these coming months. If you're interested to learn more, I invite you to come to our booth. We also have a session later today and more than 30 partners that will present solutions throughout the next 2 days. And with that, please welcome Vin.
Thank you, Gadi. All right, I know what you're all thinking. If there's not one but two AWS engineers on stage, we're probably going to build and launch a new service as we speak. You might think I'm kidding, but it is this relentless pace of innovation that brings hundreds of thousands of customers to AWS. And just for AI services alone, we now have several 100,000 customers working with the AWS platform to deliver machine learning at scale to a large number of use cases and applications. And it's by listening to these customers that we're starting to build and understand newer services and newer capabilities. And for example, some of the things that we're noticing is that the prevalence of deep learning models, and it's certainly no surprise to most people in the audience here that it's something that has seen an enormous traction in computer vision, in natural language processing, in speech and text analytics. But most of the applications today are built with frameworks that have provided the core building blocks and the structures for developing these machine learning models. Frameworks like TensorFlow and MXNet and PyTorch. And we certainly see customers coming to AWS with the need to build those models in these frameworks, and we support all of them. And one of the cool things about the AWS platform is its ability to serve all the customer needs from whatever framework and from whatever target platform they want to run these models. Now, one of the things that we've noticed is that as customers come to us, they find that it's really hard in many cases to work within this framework to build a machine learning model and to deploy it at scale. Frequently, there's a fairly complex workflow that starts with preparing the data, being able to label the data for training purposes, and then take that data and set it up in such a way that you have an environment where the machine learning model can be trained, and to create that staging environment for the machine learning model's training to be then further tuned for accuracy. But one of the key problems that we notice is that even after all this work, we still see a relatively sparse pattern of deployment of machine learning models at scale. And I say that with all humility because fundamentally, we would like to see the world infused with smart things. We'd like to see every device, every cloud-native application, every data store infused with the machine learning capabilities that are being built in the cloud. And for that deployment at scale in production, we find that there are several things that hold back the deployment. There are several things that we find developers and data scientists struggling with, and this is fundamentally the problem that SageMaker Neo sets out to solve. The first of which is that as machine learning models become more and more accurate, particularly deep learning models, they start to add many more layers to handle the representation of whatever function the model is trained to hold. And as the machine learning models get more and more complex, they tend to be attached to the framework in which they're trained, because all of these functions and primitives come from the framework. Now, taking the model out of the framework is fundamentally the challenge that we'd like to address. And the way to do that is a little hard to do when you're looking at the framework being ported to various target hardware platforms. So one of the ways we get around this is by providing what looks like a compiler as a cloud service. And it's essentially, compilers are not a new technology, but it's something that we've been working with for several decades. But the promise is essentially the same, but delivered now to deep learning models. And we look at the compiler in combination with the runtime. Fundamentally, SageMaker Neo provides this ability to abstract the model out of its framework and deploy it wherever you want it, in whatever platform. And this is how we are able to address the needs of customers like Cutling Engineering, who took this approach of taking SageMaker Neo to train a model in SageMaker, but then to optimize it for the Xilinx platforms on the edge devices as well as in the cloud. And it's this type of collaboration that we're looking to engender, to encourage with more of you, and to bring with the collaboration between Xilinx and the SageMaker Neo team, the ability to train a model in SageMaker and deploy it at scale in the cloud on F1 instances, as well as at the edge on Xilinx-based devices. So thank you, look forward to the opportunity to work with you, and with that, I'll turn it back to Victor. Thank you.
So Vin, being part of SageMaker Neo is so exciting, and Gadi, what can I say? It's been a journey already, more to come. Yep. So excited. It's been great working together with you.
Thank you
so much. Thank you.
Thank you.
Give it up for AWS. All right. Truly inspirational, right? So now let me just give you a few more examples of what Xilinx compute acceleration can do compared to traditional computing on a CPU. Twitch team, we talked about it a bit last year, but Twitch team doing streaming video saw a 30x performance boost compared to running on just a regular CPU. Illumina, another leading life sciences company, saw a 90x increase on a genomics application. And 10 Insights, which is a home video security company, achieved a 100x performance boost on their application, which, by the way, includes AI acceleration. Okay, so, but as powerful as all this is, compute acceleration is not the only place where Xilinx plays in the data center. We also play in storage and networking. So let me cover storage first. So we've been working with partners like IBM, Micron, and Samsung, who've developed accelerated storage, memory, computational storage. This is where you're processing near where the data resides. As we all know, data is absolutely exploding. It's growing at a continuous exponential, and so rapid database query response is absolutely critical. So our products can accelerate functions like compression and decompression, encryption. You could do other kinds of processing, dedupe, and so forth. And you can see performance gains of up to around 4x using a single accelerator in these devices. And we think that scales fairly linearly. Like if you see the graphic, if you add 4 more accelerators, you get about 13x. So that's really pretty cool. And again, this is being developed or deployed today. Moving on to networking, we play in SmartNICs, which the industry is just beginning to adopt, but really will be the way to go. SmartNICs provide better security by detecting and removing malicious packets, but also accelerates packet processing by offloading some of the network stack, or the network stack completely from the CPU to the SmartNIC. And that not only then relieves performance bottleneck to the data center, but it actually frees up the CPU now to do application execution, which improves the TCO. So to give you an example, on a dual socket data center server, data plane throughput gets accelerated about 3 to 6x. CPU utilization is increased by 1.5x, 50% with Xilinx-based SmartNICs. And again, because our silicon is programmable not only with software, but also with hardware, we could really customize these solutions for optimal performance in as well as unique security needs that you might have in different deployments. And we could do that all with a single common board without changing silicon or the board. Okay, so I've talked about now compute acceleration, storage, and networking, and these are things that are already deployed or well under development. So that's what's happening today. So let me share with you how we see the future of data center. And first the setup is this unrelenting demand for more computes and explosion of data. That's going to continue. So data centers of all kinds, particularly in the cloud, whether that's public cloud, private cloud, or a hybrid cloud, it's just going to continue to explode. So data center operators are absolutely looking to improve their utilization of their installed resources, improve the performance and the power efficiency, because obviously OpEx is huge, and that improves the overall TCO. So we have this term we call distributed adaptive computing, and we believe that you can achieve all of those key care-abouts by disaggregating kind of all these resources into banks of CPUs with smart NICs, with FPGAs, or in the future certainly ACAPs, those computational storage devices, as well as, of course, compute accelerators. All that connected through network, traditional networks, and also maybe additional fabrics. So these resources can then be composed on demand to meet the needs of a specific workload running in your data center at that moment. So for instance, control-intensive workloads that really need a lot of the CPU power, but at the same time has a lot of network intensity, you might want to provision that some more of those CPUs that have the smart NIC that does the offloading. Compute-intensive workloads like AI, which you just heard about, you might want to provision more of those compute acceleration resources, right? And then if you have data-intensive workloads for massive data sets, you'd obviously want to then provision more of these computational storage devices, right? So again, because our ACAPs can be optimized all the way down to the architectural level, not just at the software level, you can optimize for that specific workload that's being provisioned. And because ACAPs could be optimized dynamically, right, while it's running, you can get the benefit of hardware acceleration and very high utilization of all this distributed accelerators throughout, whether it's near the CPU, near the storage, or near the network. So what does this all mean? Distributed adaptive computing delivers to data center operators low TCO due to the dynamic optimization for workloads with acceleration and high utilization of all those accelerators in the data center. High performance and low latency, you heard that, right? So wherever you have this acceleration, not only do you have high throughput performance, but you have low latency, which is really important. And you can customize and rapidly deploy new innovations. That's what having this capability in the cloud is all about. As soon as you have maybe a new neural network, a new video codec, or whatever it is, a new way to optimize network pruning, you could quickly deploy it. You don't have to wait for new silicon or hardware. Okay, so we think that's a pretty compelling feature, but coming back to the present, the first stepping stone was just launching Alveo. Now you heard that we have a complete lineup of 16 nanometers with Verso coming in. What I'd like to do now is bring onto stage a senior technical leader for a company that's been driving the computing industry for decades. Right? And they could talk about what they're doing with Alveo now. So I'm really thrilled to welcome to stage distinguished engineer at Microsoft Azure, Miller Raghuraman. Yep. Thank you.
Hi, it's great to be here. Good morning. Today, as a result of our close collaboration with Xilinx, we are going to offer a brand new technology to meet the highest demands of our compute customers. It is no secret, we've seen tremendous growth in Azure as we've built a platform that allows anyone to harness the power of the cloud. We have compute offerings that support a dynamic spectrum of needs, from VMs supporting virtual workstations and servers to high-performance compute VMs backed by world-class cluster networking technologies. We recognize that sometimes you need specialized hardware to solve challenging problems, even problems that are tantalizingly out of reach because of Moore's law, whether due to cost or due to outright performance. We all recognize the potential of a platform that helps you use every gate of logic at your disposal to achieve more. And we've been hard at work on an incredibly simple yet powerful solution for allowing you and your customers to harness the power of FPGA acceleration at scale in production in the cloud. Today, I'm pleased to announce an all-new family of Azure VM, the NP series, along with our collaboration with Xilinx to provide even more flexibility and choice to cloud and FPGA developers alike. Whatever your scenario or business, the same designs you develop, debug, and deploy on-premise with the Alveo U250 accelerator platform will simply work in Azure. With the NP series, your design is cloud-ready with a few clicks. And best of all, these VMs will be available with up to 4 U250s and 64 GB of FPGA-attached memory on each Alveo, with 40 fast CPU cores and high-performance local storage to make sure that whatever your usage profile, you have the power you need to back it up. The power of your designs and our ecosystem, our marketplace, and together our customers. We are here to help you grow your business by offering our customers more platform choices for their business needs, whether that's live video streaming, genomics, EDA, query parsing, database acceleration, compression, speech translation, down to accelerating the designs of quantum computers and the search for new medicines. Our goal is that anything you build on-prem for the U250 against Xilinx standard SDAccel 2019.1 shell should just work to provide one of the simplest lift and shift FPGA offerings in the cloud. We recognize the unique challenges of developing FPGA designs and want to help all of you be more successful by eliminating unnecessary hassles like remotely debugging a unique hardware platform and managing a monotonically increasing matrix of deployment targets for your accelerator IP. Soon, we'll share details around a preview to help all of you get ready to intercept our customers next year with your products, and the fun really begins. With that, I hope all of you have a fantastic XDF, and thank you all for being here. Victor?
Thanks, Marco. Really thrilled to be part of Azure, and can't wait to see what many people in the audience and other developers around the world will do with your new solution. So thank you so much.
Thank you.
Yeah, thank you. All right. Okay, so, I covered a lot about the hardware aspect of our platform transformation, but platforms are both hardware and software, so let me talk about the software. Many years ago, actually approaching 10 years ago, we overhauled the very foundation of our entire software stack by introducing Vivado, right? That was a clean sheet of paper supporting hardware designers, and it's really best in class for any kind of hardware development. But we've been layering things on top of that, and we'll continue to innovate in Vivado. But as our products, our silicon architecture became more platform-centric with Zinc first and second generation, we started deploying more software around that for embedded developers, with our runtime and our SDSoC environment. For data center deployments, we had our SDXL for deployments like F1, and now you hear from Azure. Now, most recently, we've also introduced a toolkit to accelerate AI inference, and you've heard about AI also, again, with SageMaker Neo. So now our complete platforms, that's the silicon architectures, the boards with Alveo, and the software is very, very powerful, very, very complete. However, due to the evolution, right, we actually have different development environments. And, to reduce the complexity of multiple environments and to deliver a much cleaner, more productive user interface, we're going to be unifying all of those environments into a single environment. So I'm incredibly excited after years and incredible amounts of investment to do this, to announce Vitis, a single development environment for applications, or whether it's IoT, edge devices, edge computing to the cloud, communications for all markets, essentially. Okay, so Vitis is going to support those heterogeneous architectures we talked about. So our current Zinc, first and second generation, Versal A caps, of course. And the whole idea is that developers will get the productivity experience they're accustomed to in developing software, and the benefits is incredibly powerful hardware optimization without needing any hardware expertise. You heard many of the AWS customers don't know how to spell FPGA, and they're not interested in learning, by the way. Hardware optimizations can be as simple as a few critical kernels to accelerate things, but it could also be leveraging an entire domain-specific architecture, even with potentially domain-specific languages. So Vitis will be available for general access at the end of this month. They'll be supporting our current products, and then of course we have already Vitis in early access for Versal ACAP. So this is a really simplified view of the stack. Going from bottom to top, of course, we start with our boards, and again, it could be Alveo boards for the data center, but it could also be some of our development boards for Zinc, for embedded applications. And then we have, of course, compilers, analyzing other tools, and we have a number of optimized libraries for different domains, and finally support for industry standard frameworks and perhaps DSAs as well. We're delivering 8 optimized libraries, including just a couple of things like computer vision, optimized linear algebra, quantitative finance. And we'll be adding more over time. Today we support frameworks like AI and video transcoding, and we also have partners that are also supporting different frameworks, like Blacklink supports Elasticsearch. Now, right after my talk, Salil Rajay, EVP and GM of our data center group, he's going to give you more details about Vitis. But before he comes on, I get to give you share one more detail about Vitis that I think many of you as developers will like. Most developers tend to like this. It's free. It's free for all. Biggest applause so far. I guess it's not, whatever, we're not always associated with that, but free for all Xilinx boards, whether it's Alveo or embedded applications, and it's open. Right? So instead of our traditional proprietary IDE with managed projects and integrated text editor and so forth, which is very good, we've heard the feedback. Vitis plugs into standard software environments. So if you want, you could use non-standard code editors, makefile, revision control systems, right? So free and open Vitis is a win for all of you developers, and based on the applause, I guess you appreciate that, and it's really integral to our strategy. So the other thing I want to emphasize is our commitment to open source. Many people really aren't aware that we've been an active user of open source since 2001, and actually quite an active contributor since 2007. In 2018, we were the #1 contributor to U-Boot, and we co-founded OpenAMP, which is around asymmetric multiprocessing with many other software firms, and we just recently spun that off last week on the Linaro open source community project. This year, we've made open source absolutely core to our software strategy. And that is why we're making Vitis open source, standard, plugging into standard frameworks, software development environments, and free. The Vitis runtime, the libraries, the AI models, they're all available today under Apache license. Okay, so free and open should definitely drive greater adoption of our platform in all markets, and of course, especially in some of these growth markets, particularly, of course, data center. So, which brings me to the last of the markets, automotive. And this is clearly a market that everyone knows is undergoing tremendous transformation, huge disruption. And we see this as a very enormous long-term market opportunity for us and, of course, all of our customers and developers. So again, our customers could tell that story much better than I. So I'm delighted to introduce a leading supplier of automotive technology and an early adopter of both Versal as well as Vitis for ADAS and autonomous driving. Please give a warm welcome to Vice President of Hitachi Automotive Systems of the Americas, Hiroki Uchiyama-san. Uchiyama-san. Uchiyama-san, thank you.
Thank you, Victor. Good morning, everyone. Outside of the automotive industry, not many people know that Hitachi Automotive Systems has been Tier 1 supplier under Hitachi Limited over 80 years. We are producing powertrain, chassis, and ECUs for many of automotive OEMs. We have seen the bigger environment changes at increasing speed. The car now becomes more valuable for our social environment, new security and safety benefits, as well as greatly improved comfort and convenience for customers. The market shift into the ADAS, autonomous driving, EV, connected vehicles, and mobility services have been our big focus recently. Although at Hitachi, we started mass production of ADAS components back in the year 2000, having almost 20 years experience in this field. Today, we produce stereo camera, gateway, ADAS ECU, AD ECU, and other products. Here, I want to talk a little more about our ADAS AD development. Currently, we are producing level 2 products. In process of developing and launching level 2 plus to level 3 products. Even with level 2 products, the requirements and use cases are becoming more complex for next generations. There is a constant need to update current algorithm-based software. Level 2 plus to level 3, we will need to add more sensors, and sensor itself need to be updated for better performance. That means sensors output massive amount of data compared with level 2 products. All the sensors data is sent to domain controller. This domain controller recognizes real-world scenarios and determines vehicle motion. This domain controller has to handle massive data and have high calculation power. We Hitachi believe Xilinx offer attractive solution for next generation development. Xilinx has provided us their first Basel ACAP board for our development. It is powerful solutions. Basel has heterogeneous engines, SCADA processing engine, hardware engine, DSP engine. And network on chip connects these engines at high bandwidth and low latency. This engine will allow for further improvement on performance while also being easy to maintain and update. Another engine is AI engine. AI engine is an array of many vector processors which are connected tightly to each other, and in addition, access directly to hardware engine. It is optimized for AI inference, and we expect to achieve high performance. This high-performance AI solution will help to solve highly complex situations. Hitachi started evaluation of Basel ACAP board from this August using new design tool Vitis. We are now evaluating some basic functions from camera input to display output, including the object detection using AI. It's only been about 2 months since this project started, but we have already completed first demo for this exhibition. Please come to take a look at Hitachi booth. Thank you.
Uchigami-san, we're really thrilled to be working with you on advanced ADAS and autonomous driving. Thank you so much.
Thank you.
Thank you. Thank you. So as you can see, AI is being deployed in our cars. Of course, in the cloud, you heard that in the both leading cloud providers, in our homes, in infrastructure everywhere. And because our platform is being deployed from everything from cars and robots and infrastructure, grids, communications infrastructure, and data center, we're really uniquely positioned to drive AI proliferation. So we're introducing Vitis AI, which is a machine learning plugin to Vitis. So we'll be empowering AI data scientists with support for standard frameworks like TensorFlow. We're going to be delivering 30+ optimized neural network models open source to GitHub, a development kit for network optimizations like quantization and so forth, compilers, and in fact, we'll be delivering some domain-specific architectures that will enable people to get compile times of minutes, in some cases even seconds, right? So AI development on this adaptable platform really is going to drive innovation in multiple markets. And, innovation comes from many different places. Both F1 and Azure, that's enabled innovators around the planet in virtually every marketplace. We have innovation going in very large, leading customers, leading industry, but also a resurgence of startups, very innovative startups, particularly in the area of AI and automotive. So I'm really excited to introduce my last guest, who is leading a very hot startup, and they're doing both, AI and autonomous vehicles. So please welcome CEO and co-founder of Pony.ai, James Peng.
Thanks, Victor. As an early partner with Xilinx, I'm very excited to be here today. Pony.ai was founded 3 years ago with a mission to build the safest and most reliable autonomous driving solutions. We have modified existing vehicles by adding sensors and advanced AI algorithms. We have been testing our autonomous driving vehicles on challenging open urban road conditions in both Silicon Valley and Beijing and Guangzhou, China. We have been testing our vehicles and en route to make it to be product ready. So we deployed a fleet of our autonomous driving vehicles to the general public. Will be soon launched in Southern California and also in China. Besides the development on the technical side, we are also building our ecosystem by forming close partnership with leading OEMs, tier ones, and suppliers. Just about a month ago, we announced our deep collaboration with Toyota. On the supplier side, Xilinx has been one of our early partners from very early on. Let's now look at how we handle complex traffic scenarios. This is a condition where we try to make an unprotected left turn in a busy Beijing traffic. You see, we have to yield to the incoming traffic from the other side, where at the same time, there's a water truck come by with spreading the water. Right? And then after we yield all the incoming traffic from the other side, as again, this is an unprotected left turn. Then we make the turn, but at the same time, we see there's motorcycles and pedestrians, so we have to yield to them as well. And then only when we say we deemed it safe, then we make the safe passage to actually finish this left turn. Active lane change. We decide to make a lane change to right-hand side based on the situation, based on the traffic, but then because of the incoming traffic on the right-hand side, we canceled the lane change and keep on the left lane for now. And then only when we see the opportunity then we make the right turn in this case. This is another case of active lane change. We try to make a left turn. Because of the traffic on the left lane, we can only find a gap and make the lane change opportunistically. So this is the situation where we saw the gap and made the left turn. Another case of so rainy days. It's a severe weather condition we have to deal with. As I already mentioned, we're testing in Guangzhou, one of the testing sites. And it's a subtropical area. Rain is a very common weather phenomenon. So we have to deal with it day to day. And this is another case where even in a human vision, it's already very foggy and rainy, but we were able to drive still safely in a very slippery road. This is another case where we were driving between two large trucks. And if you look at carefully, we actually, in this case, swayed to the left a little bit. And then once we go forward, we saw the large truck on the left-hand side. We swayed to the right a little bit to keep safety distance. Pedestrians is common. It's hard to deal with. It's hard to recognize. This is a highway overpath. And when we make the left turn, we see the guy just wondering about his own business. And we have to recognize and keep the distance. Well, another case, this is an elementary school zone. It's a flock of elementary school kids. And we have to recognize and again, safety is critical in this kind of application. So again, as you have seen, that in order to make autonomous driving safe, we have to handle very complex traffic scenarios. And this is unique in that this kind of application plays a critical requirements on the compute platform. On one hand, we have to handle large amounts of data in real time. Right? We have to process more than 100 video frames per second. With this large amount of data, at the same time, it's a real-time application. And at the same time, because it's within the car, the power consumption is very limited. So it's all these requirements come together, requires it to be real-time, it requires low latency, it requires low power consumption, and we have to process so much data. So luckily, we partnered with Xilinx very early on and found FPGA to be a critical application in this type of usage. This table shows a result of one of the critical applications within our software stack. We can see by deploying FPGA, the latency and the power consumption have been improved for more than 10-folds. At the same time, the real-time accuracy is critical for ensuring the safety because this is a real-time application. The guaranteed deterministic latency is very critical in our application. This is another case study where we use FPGA for our sensor fusion algorithm. The sensor fusion is that we fuse the data from both the LiDAR and the surrounding cameras. One of the key challenges of sensor fusion is to make sure the time difference, the time synchronization is to the minimum. Otherwise, it's like two sensors, we're seeing two different things. On the left-hand side, we see the picture where we use traditional CPU and GPU. We can see that because the latency, the red dots are the LiDAR points. and the picture is from the camera. We can see that from the car, the discrepancy is almost nearly 1/3 of the car length. By deploying FPGA, it's on the other hand, the latency is almost to 0, and we can see the data from both LiDAR and the camera matched perfectly. So this is another case where it shows FPGA plays a critical role in our real-time application. So we have already seen great works by deploying FPGA in our mission-critical application. And with the new Vitis AI, we're even more excited to look forward to even more great things from this collaboration. Thank you all. Thanks, Victor.
Thank you so much, James. Really pretty awesome. You could tell that was real driving conditions in China if you've ever been there. So, yeah, it's really awesome to see again, all these really advanced technologies running on our, and you hear some common themes, right? High performance, processing massive amounts of data, but still real time, low latency. You hear the criticality of how that part, literally life and death, and you hear that we could do sensor fusion as well as processing. Not too many solutions can do all those different things. So, I just want to wrap this up with my personal perspective on what this forum is really all about. I really love products and technologies, 37 years in the industry. I'm sure everybody in this room feels the same way. But it's not just because it's intellectually stimulating. It's because it's really a way to make the future better. Right? You've heard some really inspiring things, right? People accelerating genomic analysis for finding genomic targeted research cures for cancer. Helping people communicate better, helping people live longer, healthier lives, solving business problems, and helping people travel much more safely and more sustainably. I mean, those are really meaningful things. So you've heard about exactly those things, as well as people who are enabling more innovation to happen on this powerful platform, more of you to use it. And that's what we're passionate about. We're passionate about helping you. And that includes all of you who have never used our products before. Right? We're actually passionate because we want to help you make that better future happen sooner. That's what's behind our transformation to platforms. That's why we did the Versal ACAP. That's why we're introducing Vitis, Vitis AI, and that's why we've embraced open source. So I really hope you use this forum to learn more about our products and platforms, to see more amazing things customers and partners are doing, and then again, out in the concourse. And hopefully that really inspires you to join us in building the intelligent, adaptable world together. Okay, thank you so much. Have a great forum. Thank you.